So in this section, what we're going to do is we're going to look at what are called angles. This is actually what we have to consider before we get to trigonometry in this class. And not only with angles, we're actually going to look at what a radian is. Okay, well first, what is an angle? Well, to get to angles, we have to know what a ray is. Really, a ray comes from a line. The idea is, if you start out, let me draw up here, with a line, okay? Remember, a line extends indefinitely in both directions. What you're going to do is this. You're going to take any point on that line, and essentially you're going to keep everything on the line on one side of the point. So essentially from here, we're just going to have this part. So everything over here, we're going to forget about. So in a sense, you could think of it as half of a line, although a line extends indefinitely, so saying half of it really doesn't make much sense. But in a sense, you could say that now this point here, we call it an end point. So now we have a ray. So a ray we have now, as you can see. And now from a ray, we actually can get an angle. How do we do that? We're going to take the ray and we're going to rotate it about the end point here. Doing so, we're going to end up with something like this. And you can imagine, let me do a different color, taking this ray and rotating it to get this. So here we have what we started with and what we end with at the same time, so to say. This here is what we call the initial side. Okay, that's the ray's starting position. The ending position is called the terminal side. And now the vertex, what was the vertex, since we have an angle now, we actually now call it a vertex. Before, it was an endpoint. But once we have the angle, we call it a vertex now. So that's the vertex of an angle. So essentially an angle, let me draw this again for fun. An angle is what you get when you rotate. An angle is what you get when you take the ray and rotate it. Okay, that's good. But now the question is, how do we measure angles? You know, just like we want to measure length, we have different ways of doing that, right? We have kilometers, we have miles. Well, for angles, there's really two units we're going to use. We're going to have degrees and radians. That's what we're going to use to measure angles. That's what the units are going to be. Now with degrees, really the best way to think of it is this. So let's say this is the starting position, okay? When you do a complete counterclockwise rotation, so the initial and the terminal side of the angle coincide, by definition, this is 360 degrees, okay? So by definition, this is 360 degrees. So I guess technically 1 degree would be 1 over 360th of this rotation, but that's kind of nasty. But for now, we could think of 360 degrees like that. Okay. So as I said before, 1 degree then would be 1 over 360th of a complete rotation about the vertex counterclockwise. That's kind of nasty, but I just threw it in there just to be complete, I guess, so to say. Also note that units for degree, the notation for the degree. It looks like a little circle here. You can see it over here. So this is actually 90 degrees. That's what this little circle is. And speaking of 90 degrees, that's actually 1/4 of a complete rotation. So in other words, 90 degrees is going to look like this. So this is actually 90 degrees. And again, we're rotating counterclockwise. We're not really going to see this too much in this class, but if you go on to pre-calc and other classes, math classes, if you were to rotate clockwise, that angle would be negative, and that's just by definition. 180 degrees, that is when you do an about face, so to say. It's half of a full rotation. So, in other words, the terminal side and the initial side, they're going to be opposite. They're going to be facing opposite direction. Okay, now we're ready to get to radians. We're actually not going to see the formal definition of what a radian is. There is a formal definition. For time consideration, though, I'm going to skip over that. Really, for this class, what you need to know is how to convert between degrees and radians. It's actually not that bad to do that, and it's really just given by these statements. To go from degrees to radians, you're going to multiply by pi over 180. It actually turns out that pi radians equals 180 degrees. As you can see, that actually turns out to be true. And from there is how you get the first and the second actually conversion formula. So again, the first one is to go from degrees to radians, you're going to multiply by pi over 180. To go the other way, though, radians to degrees, you want to multiply by 180 over pi. And that's really what you want to know. So as a quick example, 90 degrees, okay, how do we get that into radians? We're going to multiply by pi over 180. So what we get is 90 pi over 180. Well, 90 over 180 is the same as 1 over 2. So this becomes pi over 2 radians. Notice we didn't write out the word radians. That's a convention that mathematicians use. They just don't write out the word radians. So if you see an angle and you don't see the units, you can assume it's in radians. Radians turn out to be very useful, especially when you get to calculus, but that's another story. 270 degrees, again, same idea. You multiply by pi over 180, you get 270 pi over 180, and it's good to reduce that, of course. What you end up getting by reducing it is 3 pi over 2. Basically, 270, let me see if I can show this quickly, 270 pi over 180, that's actually the same as 90 times 3 times pi. 180 is 90 times 2. So you can see the 90s are actually going to cancel. So that's why we get 3 pi over 2. Now going the other way, just for practice, 2 pi over 3 radians, right? We want to get that into degrees. We're going to multiply by 180 over pi. That's what we're using here. So multiplying it, the pi's cancel. As you can see here, we get 2 times 180 over 3. But again, 180 over 3, that's just the same as 60. So we get 2 times 60, which is 120 degrees. You know, we want to put the units in, so that's why we have this little circle here, which means degrees. Then we have these two other examples. They're pretty self-explanatory. Same idea as this one. You multiply by 180 over pi. 180 over 3 we just said is 60. So, and the pi's cancel, we get 60 degrees. Pi over 3 is also 30 degrees. Again, it's just an easy calculation. Let me just do one more, just for fun. If you have pi over 4 radians, well, to convert it to degrees, again, you have to multiply by 180 over pi. Okay, now what is this going to be? Well, you're going to get pi times 180 over 4 pi. Okay, that's not bad. But now we can do better than that. For one thing, the pi's cancel, so those are gone. 180 over 4 is actually 45, so we get 45 degrees.